So write down this question, which is continuation of last class. In which of the following compounds nitrogen shows highest oxidation number? Is it visible to all of you?
Yes, sir.
Oh. Number A, N2H4. Number B, NH3. Number C, N3H. Number D, NH2OH. Paribane koribo?
Yes, sir.
Yes, sir.
Try kora. So calculate the oxidation number of nitrogen in all the different compounds following the rules that I have given you in the last class. And thereafter, you will have to find out that in which of the compound nitrogen has maximum oxidation number. Could you find out the first one?
Yes, sir. +2.
So nitrogen যেহেতু ওলাবলে দিছে আমি x বলি ধরিম and each hydrogen is +1 as they are not metal hydrides. We can take
-2.
So x will come out to be
-2.
-2. So we put the value of x to be -2. Nitrogen oxidation number is -2. Similarly, what is the oxidation of nitrogen in the second one? -3, I believe.
3.
So, -3.
-3. You must give plus or minus. What about the next one?
So, -1/3.
1/3.
It is -1/3, isn't it? And what about the last one? X plus their
-1.
hydrogens. Oxygen will be considered as -2. X will be -1, isn't it?
Yes, sir.
So all are negative values, and within them you are to find out that which is the highest oxidation number. So will it not be C?
Yes, sir.
Yes, it will be C because -1/3 is the maximum value, because as we put negative sign, the reciprocal develops greater value. Clear or not? Any doubt?
Clear.
Okay. Can I rub it? Any doubt if you have got, please clear it out before I go to the next topic. No doubt?
Sir,
Yes.
sir, number D, itu 3 into plus 1 hobo no?
3 into plus 1 because there are 3 hydrogens na.
Sir, ঠিক আছে.
3টা হাইড্রোজেন মই একেলগে কাউন্ট কৰি দিছো.
ঠিক
ঠিক
আছে,
আছে?
sir.
Okay. So just to find out that whether you remember the rules or not, I gave you this question. So thereafter, we'll talk about another very, very important topic. And in general, questions are asked from this topic, both in class 11 as well as class 12. So right, predicting the oxidizing and reducing nature, predicting the oxidizing and reducing nature of species. Okay, so we have already discussed that oxidizing agents themselves get what?
Reduce.
Yes, oxidizing agents gets reduced. They oxidize others. So last class we have discussed, but they themselves get reduced. And what is the meaning of the term getting reduced? It means they gain electrons, isn't it? Getting reduced means what? Gaining electrons or not?
Yes, sir. Yes, sir.
Now, when any oxidizing agent gains electron in terms of oxidation number, if it is asked, what will happen? Will the oxidation number increase or will the oxidation number decrease? What do you think? If anyone gains electron, its oxidation number will increase or will it decrease?
Sir, decrease.
Sir,
It will decrease. Yes, because gaining electrons means what? Developing more negative charge or not?
Yes, sir.
Okay. If they develop negative charge in them, so obviously their charge will decrease, isn't it? From positive to negative. So as I said, oxidizing agents gain electrons during the process. So oxidation number of oxidizing agents decrease. See if you have got any doubt, anyone, please clear it out. Is this point clear? Because oxidizing agents gain electrons, and gaining electrons means gaining negative charge. So if they gain negative charge, so there is a decrease in the oxidation number. It is like saying that suppose we have Fe plus 3, accepting the electron, it converts to Fe plus 2. So can we call the Fe3 plus is undergoing reduction or not?
Yes, sir.
Oh. So if Fe3 plus is undergoing reduction, so its charge is decreasing. It was previously plus 3 and now it is becoming plus 2. So this has to be taken care of, that if Fe3 plus in any reaction is used and it is accepting the electron, so where from it will accept the electron? The other, which is not mentioned here, must lose the electron. Then only it can gain the electron. So when it gains the electron, its oxidation number decreases. So always remember that oxidation number of oxidizing agents decrease during redox. Same way, if you put this one as number 1, reducing agents. What do the reducing agents do? They get oxidized or not?
Yes, sir. Yes, sir.
They get oxidized. Okay. And getting oxidized means what? They lose electrons or not?
Yes, sir. Yes, sir.
Now, if they lose electrons, negativity will decrease, positivity will increase. So oxidation number will increase. Yes?
Yes, sir.
The oxidation number of reducing agents increase. So if you just reverse this equation, so we can say that Fe2 plus changes to Fe3 plus electron. So here the role of Fe2 plus is reducing agent because it is losing the electrons. And when it is losing the electron, is not the oxidation number increasing?
Yes, sir.
Okay. Up to this much it is clear?
Yes, sir.
Okay.
Sir.
Yes?
Sir, তলৰখিনি দেখা পোৱা নাই।
তলৰখিনি দেখা পোৱা নাই? ৰবা। দেখা পাইছা?
sir.
Okay. How you are keeping your mobiles? Horizontally or vertically?
Horizontally.
Keep it horizontally so that you can get the full screen. Vertically as such, my writing is small. So you have to use binoculars to see it, isn't it? Okay, can I proceed? Is it clear up to this much?
Yes, sir.
Okay. Now, every one of us has a capacity of doing something. Some people are capacious of doing more. Some people are capacious of doing less. And everyone has got a different capacity. And based on this, we will be capable of finding that if you are given one particular element, what is its range? That means for every element, there is a range. Say, for example, when we are talking about nitrogen, we know that it has got electronic configuration of 2,5, the normal electronic configuration, which means that if it wants to be a stable gas, so there are two possibilities. Either it can gain 3 electrons to become 2,8, and gaining 3 electrons means it will be having the tendency of developing -3 charge, or it can lose 5 electrons so that it becomes 2, and losing 5 electrons means it can develop +5. Is it understood or not? Just see.
Yes, sir.
So what are the two nearest stable gas configurations near nitrogen? It is 2 for helium and 2,8 for neon, isn't it? And in between there is nitrogen, 2,7, 2,5. So in order to become helium, it is supposed to lose 5 electrons. And in order to become neon, it needs to gain 3 electrons, isn't it? And that is why we can say that the range of nitrogen is from, according to number line, -3 to +5. It can show oxidation state starting from -3 to +5. See whether it is clear or not. It's a very, very important concept.
Sir, can you repeat it again?
Okay. Nitrogen's electronic configuration is 2,5. And what are the nearest two stable gas on the two sides. One is helium and the other is neon or not?
Yes, sir.
So if nitrogen wants to achieve the electronic configuration of helium, will it not lose 5 electrons?
Yes, sir.
And if anyone loses 5 electrons, means it is capable of showing oxidation state of +5 or not?
Yeah, yes, sir.
Okay. Again, if nitrogen wants to get converted to neon, then what is it supposed to do? 2,5 যদি 2,8 হবলে বিচাৰে, what it is supposed to do? Will it not gain 3 electrons?
Yes, sir.
Okay. So if anyone gains 3 electrons, will it not show oxidation state of -3? Yes or no?
Sir.
Okay. So minimum oxidation state nitrogen can show is -3. And maximum oxidation state nitrogen can show is +5. Here,
Yes, sir.
it cannot show oxidation state lesser than that of -2. -2, -1 can be shown, but -4, -5, -6 cannot be shown. Understood or not? Because you all are familiar with number line, isn't it?
Yes, sir.
Okay. So it can show oxidation state of -3 to +5 only. It cannot go towards the left hand side. It cannot go towards the right hand side. So if it is asked that can nitrogen show oxidation state of +6, answer will be no. Can nitrogen shows oxidation state of -4? Answer will be no. Understood or not?
Yes,
sir. Yes,
Okay. So this is the minimum value. This is the maximum value. If the nitrogen in any compound is in this oxidation state, remember, then it can move only in this direction. And if it moves only in this direction, what actually it is supposed to do? Should it gain electron or should it lose electron?
Sir, lose electron.
It can only lose electron, because gaining electron will make it -4, which is impossible. So therefore, if the nitrogen in any compound shows oxidation number of -3, then it is in position of only losing electron. Now, who loses electron? Oxidizing agent or reducing agent?
Sir, reducing agent.
Reducing agent. So therefore, if nitrogen in any compound has -3 oxidation state, it can act only as reducing agent. Clear or not?
Yes, sir.
Okay. In any compound, if nitrogen shows oxidation state of +5, what it can only do?
Sir, gain electron.
It can only gain electron. It cannot further lose electron, because it cannot bear more positivity beyond +5. So it can only gain electrons. If it gains electron, what it can act as?
Sir, oxidizing.
Only oxidizing agent. Clear?
Yes, sir.
Okay. But if in any compound nitrogen shows oxidation state of, say, +3, what it can do? It can go this way also, it can go this way also, not?
Yes, sir.
Because it is neither highest nor lowest, it is in between, it is intermediate. So if oxidation number of nitrogen is +3 in any compound, then what it can act as? Can it act as only reducing agent or only oxidizing agent, or it can act as both?
Both.
It can act as both. Understood?
Yes, sir.
Everyone is clear or not? Tell me.
Yes, sir.
Yes.
Clear.
Yes, sir.
Okay, fine. Now, if it is clear to you, then Suppose you are given a question. That there are some compounds of nitrogen, NH3, HNO3, NO2, HNO2. Okay, so all of them have nitrogen as the central atom. So what is the range of nitrogen just now we have discussed?
Sir, -3 to +5.
Very good. -3 to +5. Now we will individually calculate the oxidation numbers of nitrogen in all the 4 different compounds. Suppose in NH3, we have already calculated in the previous question. It is x plus 3 into +1 equal to 0, implies x equal to -3, isn't it?
Yes, sir.
Okay. It means that in NH3, nitrogen is in its lowest oxidation state. And if it is in its lowest oxidation state, it can only lose electron. It cannot gain electron. So what will be the role of NH3 in any reaction?
Sir, reducing agent.
Only reducing agent, isn't it? Understood?
Yes, sir.
Buji paisa na sobe?
Yes, sir.
Likewise, you calculate the nitrogen's oxidation state in all the different compounds and tell me what will be the role of nitrogen in the different compounds. Could anybody get the second one?
Yes, sir.
What is
Oxidizing.
the answer?
Five.
Only oxidizing agent. What about the third one?
Both.
Tell me what is the third one? Oxidation number, how much you are getting the third one?
+4.
+4. So is +4 an extreme value for nitrogen or is it an intermediate value?
Intermediate.
Sir,
It
intermediate.
is intermediate. So if it is intermediate, so it can act as both or not?
Yes, sir.
Yes, sir.
Yes, sir.
Move to the last one.
+3.
How much you are getting? +3.
Yes, sir.
+3.
So +3, what will you suggest? HNO2
Intermediate.
can act as both?
Both.
Yes. Is it clear?
Yes, sir.
So to predict the oxidizing or reducing nature of any species, you have to calculate the range for the central atom. In all these 4 compounds, the central atom was nitrogen, and that is why we have calculated the oxidizing and reducing nature. And before that, we had to calculate the range for the nitrogen. Understood? Can I move on?
Yes, sir.
Okay. Now suppose instead of nitrogen compounds, if I give you sulfur compounds, H2S, H2SO4, SO2, SO3. Okay. So obviously this time the nitrogen's range will not help us. We will have to calculate the range for which element now?
Sulfur.
Sulfur.
Sulfur. Atomic number of sulfur is 16. So it is 2, 8, 6. So what do you think will be the range for sulfur to achieve the nearest stable gas configurations?
Gain 2 electrons, so -2.
So -2 to +6.
Very good. Is it clear to everyone?
Yes, sir.
If it gains 2 electron, it becomes 2, 8, 8, which is a stable configuration. And if it loses 6 electrons, it becomes 2, 8. So gaining 2 electron will be -2 and losing 6 electrons will be +6, which means that the lowest possible oxidation number for sulfur in any compound is -2 and highest is +6. Clear?
Yes, sir.
Now, same way, you tell me what will be the nature of sulfur in the different compounds? Will it act as both, or will it act as only oxidizing agent or only reducing agent?
Sir, one is reducing agent.
Very good.
Number 2 is only oxidizing.
Fine. What about the next?
+4.
So, what do you think is the result?
Both. Only oxidizing.
Gas is oxidizing agent.
I hope it is clear now.
Yes, sir.
Okay. Any doubt in any one of them? Clear it out. No doubt?
No, sir.
Okay. Try out carbon dioxide and carbon monoxide. Whose range you will calculate at first in both these compounds? Who is the common element?
Carbon.
Sir, carbon.
Of course, carbon. So just tell me the range for carbon first. If your range is correct.
-2 to +4.
No. Anyone?
Sir, -4 to +4.
-4 to +4. Carbon atomic number 6 is 2, 4. So its range will be -4 to +4, isn't it?
Yes, sir.
It will lose 4 electrons to become 2, and it will gain 4 electrons to become 2, 8. Now individually calculate the oxidation number of carbon in both these compounds and tell me.
First is only oxidizing.
Sir, first is oxidizing.
First is only oxidizing, fine.
Second is both.
And second one will be both. Anyone who is not getting or not understanding why the first one is only oxidizing and second one is both, please ask me. Is it understood?
Yes, sir.
Yes, sir.
So it is not very difficult for us to understand once we are capable of calculating the range. See, every element has a range. It cannot accept or it cannot lose any electron of its choice. It is just like saying that every one of us has a range. We have taken birth in this world and we can do up to a certain level according to our capacity. And every person has a different capacity. And accordingly, we should do to the fullest. Okay. And exactly that way, an element will have a minimum oxidation state possible and a maximum oxidation state possible. The first important application that we have just now learned is with the help of the range, we can calculate the role of a particular compound in which this element is the central atom to act as oxidizing agent, to act as a reducing agent, or it can act as both. Understood?
Yes, sir.
I hope it is clear now to everyone.
Yes, sir.
Now, if you come across the question like why HNO3 can act only as an oxidizing agent, but HNO2 can act both as an oxidizing as well as reducing agent, you are now in position to answer it that the maximum oxidation state of nitrogen is how much? +5. And minimum oxidation state of nitrogen is -3. In HNO3, nitrogen shows maximum oxidation state of +5, and therefore it can only gain electrons to act as oxidizing agent only. But in HNO2, nitrogen shows oxidation state of how much we calculated? +3, which is an intermediate between the highest and lowest. And therefore, in HNO2, the nitrogen can both gain electron as well as lose electron, thereby making HNO2 both as an oxidizing agent as well as a reducing agent. Understood?
Yes,
Yes,
sir.
Okay, fine. So after knowing the range of every element, we go to another interesting aspect with the help of which we can say that there are certain compounds which do not follow the normal oxidation number method. So we discuss them under the topic exceptions to oxidation number rule. There are few exceptions. So we have discussed some rules to be followed. In general, the normal rules that we follow is oxygen should be normally taken as -2. Hydrogen should be taken as +1 in almost all its compounds. But within the rule, I had given some exceptions that oxygen is always not going to show -2. There are some exceptions where it can show -1, -0.5 as well. So how, with the help of the range, we can predict that according to the normal oxidation number rule, if we calculate, the answer comes out to be wrong and it is not acceptable. Let us try out some examples. Suppose you are given this particular compound CrO5, where chromium is associated with 5 oxygen. And if you follow the normal rule, normal method, according to which the oxidation state of oxygen should be taken as how much? -2, isn't it?
Yes, sir.
So with the help of oxygen, if we are assigned to calculate the oxidation number of chromium, so let chromium be X. This will be 5 into -2 equal to 0. So X comes out to be +10 by normal method. Okay. Now let us see that is it possible to have chromium to accept this value of +10? Is it in position of losing 10 electrons? Chromium, whose atomic number is 24, is 2, 8, 8, 6, isn't it?
Yes, sir.
Okay. Now, according to its electronic configuration, how many electrons it is in position to lose to get the maximum oxidation state?
Sir,
6
6.
electrons.
6, which means what is the maximum oxidation state possible for chromium?
Sir, +6.
+6. That means it is not acceptable, isn't it?
Yes.
sir.
Okay. That means we cannot consider all oxygen atoms as normal oxygen atoms, because if we consider all the oxygen to possess -2 oxidation state, then on the basis of oxygen, we are getting some abnormal value for chromium, which is not acceptable for chromium. So in order to understand it, we will have to look at the structure of chromium peroxide. It has a butterfly type structure. It looks like a butterfly, because of which it is said to have butterfly-like structure. Now, the moment I draw the structure of chromium peroxide, so we see that not all oxygens are normal oxygens, because if oxygen is present in this bonded form, we call these oxygen as peroxo-oxygen, and this linkage is called peroxo linkage. Now go to the rule for oxygen, where we have discussed that for peroxo linkaged oxygen, what should be the oxidation state taken for oxygen?
Sir, +1.
No,
-1.
-1.
-1.
-1. That means these oxygens are not to be given as -2, as they are peroxo linkaged oxygen. Only this oxygen is normal oxygen, so it should be -2. Clear?
Yes, sir.
Okay. Now count on the total minuses, how much it is coming out to be?
-6.
-6. So if oxygens are -6, how much should be chromiums? Should it be +6 or not?
Yes, sir.
Now is it acceptable?
Sir.
Yes or no?
Yes, sir.
Now it is acceptable, which means by normal method, we are getting some abnormal values, which is unacceptable, because chromium is not in position of showing oxidation state of +10, and we have confirmed it by looking at the electronic configuration of chromium, where we see that chromium can maximum lose 6 electrons, which means that it can show maximum oxidation state of +6, and therefore we'll have to draw the structure and look at the actual situation of the oxygen atoms, and thereby we can make out that no, all oxygens are not -2 oxygens, 4 of them are -1 oxygens. Understood?
Yes, sir.
So there are few exceptions which you'll have to remember. This is one of them, which is very commonly asked. Can I move on to the next one?
Yes, sir.
Okay. Number 2, H2SO5, which is also called Carrot's acid. Carrot's acid. Now tell me first, by normal method, how much the oxidation number of sulfur comes out to be? How much is it coming out? Plus?
8, sir, plus 8.
Plus 8. Okay. So by normal method, you have told me that if I give +1 to hydrogens, X to sulfur, X should come out to be +8. But sulfur, whose atomic number is 16, is 2, 8, 6. What is the maximum oxidation number possible for sulfur? +6,
Plus
isn't it?
6.
It cannot go beyond +6, which means not all oxygen atoms are normal. Let us look at the structure of Carrot's acid. Now, if you look at the structure of Carrot's acid, tell me how many oxygens are peroxo linkage?
Sir, 3.
No. This oxygen is not peroxo linkage. In order to be peroxo linkage, it should be oxygen single bond oxygen.
2.
Only 2. It means this should be -1, this should be -1, hydrogen should be +1. All other oxygens are normal. Now you calculate all different values surrounding the sulfur, and on the basis of all these elements, tell me how much is sulfur coming out. Yes?
+6.
+6 you are getting or not on sulfur? See, all of you are getting or not? -1 +1 cancels. Then +1 -1 cancels. So how many -2s are remaining?
Sir, 3.
3. So is it not -6 as a whole?
Yes, sir.
Yes, sir.
So what should be the oxidation number of sulfur? +6.
+6.
Is it acceptable now?
Yes, sir.
Understood?
Yes, sir.
So first we will proceed by normal method, and then we will see if exceptionally abnormal values are coming out. So we can see that no, it is not acceptable. It means that we will have to look at the structure of the molecule, and not all oxygen which are present are normal oxygens. Some of them are peroxo linkaged oxygens, and don't think that single bonded oxygen are peroxo linkage. No, oxygen singly bonded with another oxygen are peroxo linkaged. Clear?
Yes, sir.
Next, another very important molecule which falls under the exception is CaOCl2, which we better know it as bleaching powder. Bleaching powder. So what I want you to do is you calculate the oxidation number of chlorine with the help of normal method, and then I'll draw the structure to see exactly or actually what is the scenario. Use the normal method. How much will you take for calcium?
Plus 2.
Plus 2, because calcium belongs to group 2, and in the rule I have already told you that group 2 elements lose 2 electrons and therefore they will be plus 2. How much is oxygen?
X equals 0.
Here the oxygen should not have any problem because it's a single oxygen, it has to be minus 2. So accordingly chlorine should come out to be how much? Yes, anyone who can clearly tell me?
0.
0. Chlorine should come out to be 0, isn't it? Yes or no?
Yes, sir.
Okay. Calcium plus 2, oxygen minus 2, chlorine 2x equal to 0. So 2x is 0. It means x is 0. So chlorine should show, both the chlorine atoms are supposed to show oxidation number of 0. But actually it is not so. Why? Because if you look at the structure of bleaching powder, it is this. And as it is clear, both the chlorine atoms are not in the same environment. And accordingly, the oxidation numbers of both the chlorine atoms should be different. And how to calculate the oxidation number of chlorine, both the chlorine atoms separately? Let us see. In general, calcium is plus 2, always plus 2 in combined state. And chlorine, when present alone, will be minus 1 because it's a halogen. And because it's a halogen, it is always having the tendency of accepting 1 electron. It is 2, 8, 7. So chlorine is minus 1. Now, if it is plus 2, this is minus 1. This as a whole should be what? If this is plus 2, this is minus 1, then this as a whole should be what? Can anyone tell me? So that overall
Minus
charge
1.
is 0, minus 1. Yes,
Minus
it is minus 1.
1.
Is it understood?
Yes, sir.
Okay. But this minus 1 is a combined value of O and Cl. And from this, if you need to calculate the oxidation number of chlorine alone, so can we say oxygen is minus 2, chlorine is x, and overall is minus 1? Yes or no?
Yes, sir.
So accordingly, what will be the value of x? Is it not plus 1?
Yes, sir.
Okay. So it means that though there are 2 chlorine atoms, but both the chlorine atoms are in different oxidation states in bleaching powder. One of the chlorine atom shows oxidation number of minus 1. Other chlorine atom shows oxidation number of plus 1. But as a whole, if you want to calculate, the answer comes out to be 0 because the average of the 2 is 0. But that does not mean both of them are 0 individually. Just now, as we have seen with the help of the structure, that one of the chlorine is minus 1 and another chlorine is plus 1. Here,
Yes, sir.
the 2 chlorine atoms in CaOCl2 show oxidation number of minus 1 and +2. So none of them are 0. Clear?
Yes, sir.
Okay. So just remember the exceptions that I am giving, because these are the most common exceptions which are generally asked. Can I proceed further?
Yes, sir.
Okay. Let us move on to the fourth exception. Fe3O4. Now by normal oxidation number method, you tell me how much should be the oxidation state of iron?
Plus 8/3.
Plus 8 by 3. Fine. See, others are getting or not? Plus 8 by 3. Let iron be X. All oxygens -2. Is it not plus 8 by 3? Yes or no?
Yes, sir.
Yes, sir.
Okay. But the confusion is iron exists in the nature either as Fe+2 or Fe+3. But here what you are getting is unusual. How can iron show plus 8 by 3 a fractional value? Because iron should be either +2 or +3. Plus 8 by 3 is not possible for iron. It means that this Fe3O4, even though it is written in combined way, it is a mixed oxide. And actually Fe3O4 is to be written in this manner. Okay, Fe3O4 is an oxide which contains in it both FeO and Fe2O3. And when you combine these two, so it actually becomes Fe3O4. Now, what is the oxidation state of iron in FeO? Just
Plus.
forget about this.
+2.
It is -2. So will it not be +2?
Yes, sir.
That means it is acceptable. Similarly, if this
+3.
is -2, will it
+3.
not come out to be +3? This is also acceptable, isn't it?
Yes, sir.
That means when you calculate in a combined way, it comes out to be plus 8 by 3. But actually, it is not plus 8 by 3. Some iron are present in the form of +2 and some iron are present in the form of +3. Because iron can never show oxidation state different from +2 or +3. But because it is written in this manner, it confuses us and we report the oxidation state as plus 8 by 3. But if you go deep into the structure, Fe3O4 actually is FeO dot Fe2O3. Clear? Yes or no?
Yes, sir.
তার মানে main কথাটো হল, if you take a sample of Fe3O4, it is not formula of a particular compound. In that sample, some portion is FeO and some portion is Fe2O3. So as a whole, if you calculate the average value of all the iron together, it comes out to be plus 8 by 3. But if you individually calculate, so those which are having FeO composition, iron will have +2, and those who have composition of Fe2O3, iron is +3. Clear?
Yes, sir.
So whenever you get fractional oxidation state, it might bring us some question in our mind that how is it possible that the electron has been fractionalized? Electron can never be fractionalized. Either it will be a -1 or +1, or -2 or +2. It should be in whole numbers. But why then, in some cases, we are getting the fractional values? It is because you are actually getting the average of all who are present in different oxidation states in mixed states. Understood? Yes or no?
Yes, sir.
See, I give you a very simple example. If I say that the average income of an Indian is 75,000 rupees, does that mean everyone has the income of 75,000 in this country?
No, sir.
No. It is a mixed value. That means when I add up the total income by the total population, that comes out to be 75,000, which is an average value. And average is mostly different from that of the reality. In this formula, the richest persons are also included and poorest are also included. That does not mean the richer one is having the income of rupees 75,000, nor does it mean that the poorest one also gets the income of 75,000. It's a mixed value. So same way, when I say iron has oxidation state of +8/3, none of the iron has actually +8/3. Iron present is either in +3 oxidation state or in +2 oxidation state. It is the average value that we are in. Is it clear now?
Yes, sir.
Yes, sir.
Now let us move on to another such example. Suppose you are given NH4 NO3, ammonium nitrate. How many nitrogens you are able to see? There are 2 nitrogens. Okay. Now, if you are asked to calculate the oxidation number of nitrogen, both the nitrogen are present in different environments. So it will be improper to mix them up and calculate. So how will we calculate it? We'll first break it down into their respective ions, ammonium ion and nitrate ion. And thereafter, we'll calculate the oxidation numbers of nitrogen separately in these two. Now tell me what will be the oxidation state of this nitrogen and what will be the oxidation state of this nitrogen.
So -3 and 5.
Let us see. It is x plus 4 into +1. Overall is +1. X will be -3. Fine. This is x plus 3 into -2 equal to -1. Are you getting these two values? Yes or no?
Yes, sir.
Yes.
Oh. That means that even though there are 2 nitrogens, but both of them are completely in different oxidation states. One of them is -3 and one of them is +1. But if I would have mixed them, saying that this is x, this is also x, I would not have got any one of these values. Rather, I would have got the average of 2 values. Is it clear now?
Yes, sir.
So these are some of the exceptions that you need to take care of. Can I proceed further?
Yes, sir.
Okay. Sometimes you might come across such type of compounds where you need to calculate the oxidation number of iron. And such type of compounds in which third bracket is used are given a special name called complexes, by coordination compounds, which you will be getting in class 12. Now, in order to get the oxidation number of iron, you must know what is the oxidation number of potassium, and you must know what is the oxidation number of carbon and nitrogen. But the problem is, potassium, it's okay, it falls under the rule because potassium belongs to group 1, so it will be +1. But the problem comes with the CN as a whole. So remember, here you need not consider carbon and nitrogen individually, rather it is to be considered as cyanide ion. Whose formula is Pn minus. So when carbon and nitrogen are present in this form of Cn, this should be considered as a group and it is called an anion with -1 charge. So as a whole, each cyanide should be considered as -1. Just like that, if you come across SO4, we know that it is a compound ion and therefore the charge of SO4 should be considered as -2. Carbonate ion, CO3 2-, isn't it? So likewise, you have to take as a whole charge. Now you put in for each cyanide -1 and tell me what is the oxidation state of iron coming.
+6.
+6 is not allowed for iron beta. How much should be the oxidation state of iron? Each potassium is +1. Have you taken +1 for potassium?
Yes, sir.
Iron is X and each cyanide is -1 and overall is 0. Okay.
Yes, sir.
So accordingly, what will be the value of X? Will it not be +2? Just see.
Yes, sir.
Similarly, try out for this Na3 FeCN6.
+3.
+3. Are you getting +3, everyone? What will you take the oxidation number of sodium? It belongs to group 1. So just like potassium, sodium should also be +1, isn't it?
Yes, sir.
This is -1 each. So accordingly, when you put it in the formula, it will come out to be +3. Clear? Understood?
Yes,
Yes,
sir.
sir.
Oh, fine. So remember all these exceptions. It will help you out. Suppose you come across some exceptional compounds in the exam. So always we should not follow the normal rule. Mostly we will follow the normal rule, but sometimes it may not be possible. Okay. After this, we move on to the next topic, right? Stock notation. Stock, S-T-O-C-K. Name of the scientist who introduced this notation for writing down the names of those elements which show variable oxidation state. Let me give you the example. Before going to the example, if an element A shows two types of oxidation state, lower and higher. Previously, for lower oxidation state, we used to use the term us, and for higher oxidation state, we used ik. Say for example, Fe is the element and higher oxidation state of iron is Fe plus 3, lower oxidation state is Fe plus 2. Now when iron is in plus 2 oxidation state, it will be called as ferrous, and when it is in higher oxidation state, it will be called as ferric. Similarly, if you have tin exists in two oxidation states, Sn plus 2, Sn plus 4. The higher oxidation state and lower oxidation state accordingly will be called as stannous and stannic. Are you understanding the point?
Yes,
So
sir.
can you explain again?
তার মানে যদি এটা এলিমেন্টৰ দুটা অক্সিডেশন স্টেট থাকে, লোৱাৰৰ কাৰণে আমি আস টার্মটো ইউজ কৰো and higher কারণে আমি ik টার্মটো ইউজ করুম। তো আয়রন ধরা shows two oxidation state +2 and +3, তো lower +2 হল না নাই?
Yes, sir.
তো লোৱাৰৰ কাৰণে আমি ফেরাস আৰু হায়াৰৰ কাৰণে ফেরিক ইউজ কৰিছি। টিনৰ দুটা অক্সিডেশন স্টেট এক্সিস্ট কৰে, +2 আৰু +4, তো +2 ক আমি স্ট্যানাস বলি কম and +4 ক স্ট্যানিক বলি কম, বুঝিলা?
Yes, sir.
So these were classical ways of representation. Classical ways mane ki older ways. But Stock introduced a simple way of expressing the name of such compounds. Let me give you the example. Etya dhara, you are given the compound FeCl2. Classical mote tar naam tu ki asile? What is the oxidation state of iron in FeCl2? Chlorine যদি -1 ধরা হয়, আয়রনের কিমান হবে? +2 হবে না? তো ক্লাসিক্যাল নাম তার আসলে কি কি লিখিম? ফেরাস না ফেরিক?
Ferrous.
ফেরাস ক্লোরাইড। আর যদি FeCl3 হয় কি নাম দিম?
Ferric chloride.
ফেরিক ক্লোরাইড। Okay, Stock notation says that no need of writing ferrous and ferric. You simply write the same name for both of them. It will be iron, put a first bracket chloride. You write iron, chloride. Both are iron chlorides. But what is the basic difference? The basic difference lies in the oxidation state. Whereas this one shows oxidation state of +2, So in Roman numeral, you write the oxidation state. Is it clear?
Yes, sir.
Yes, sir.
So you need not remember the terms like ferric or ferrous. Let the name be normal name and both are iron chloride. But within first bracket, after writing the name of the metal who is showing variable valency, accordingly, you have to write down the names. So tell me, what will be the stock notation for SnCl2 and SnCl4?
So tin 2 chloride.
Very good.
Tin 4.
Tin 2 chloride. Aru tin 4 chloride. Buji paisa?
Yes, sir.
Yes, sir.
So it is more simple because here it is solving two problems. You may not be aware which is the lower oxidation state and higher oxidation state, with whom we should put us and with whom we should put ik. So therefore, no need of remembering all these. You simply write down the name of the normal molecule, but within bracket, you can put the oxidation state, which you can calculate by normal method. Is it not? Bujila?
Yes, sir.
Okay. एक एटा स्टॉक नोटेशन लिखा मैं मॉलिक्यूल्स केटा मान कोई दूं CuI CuCl2 FeO Fe2O3 MnO Mn2O7. Iodine is a halogen. All halogens generally show oxidation state of -1. Fluorine, chlorine, bromine, iodine show normal oxidation state of -1. So what name would you give to the first one?
Copper 2 iodide.
Copper 1, na? 1 hobo to? If this is -1, this has to be +1 or not? What is the name of the second one?
Copper 2 chloride.
Copper 2 chloride. Fine. Third one.
Iron 2
Iron 2 oxide. Next one. I wanted to get from any girl. Calculate the oxidation state of iron and tell me. কি হবো?
Iron 3 oxide.
Next.
manganese 2 oxide.
Manganese. Write the name of the metal as usual. Manganese, key oxide,
Sir, 2
2
oxide.
oxide. Yes. Last one. What is the oxidation number for manganese you are getting by normal method?
7.
Sir, 7.
Manganese 7 oxide. ठीक है sir?
Yes, sir.
So if it strikes in your mind 7 is too large value, is it possible for manganese to show 7? Let us see. Manganese has atomic number of 25, 2, 8, 8, 7. So is it possible to show plus 7?
Yes, sir.
Yes. So it is allowed.
Yes, sir.
Clear or not?
Yes, sir.
So otherwise we were using the term as ferrous oxide, ferric oxide, cupric chloride, cuprous iodide. So you need not now remember the terms us and ik, because stock notation eases the way of naming, and you need not have the knowledge of lowest oxidation state or highest oxidation state. And apart from that, not all elements have only 2 oxidation states. There may be more than 2 oxidation states. So there is confusion. If it is 2, yes, us and ik can be used. But if it is more than 2, then what name should be used for everyone? So to avoid all such confusions, we have used the stock notation. Understood?
Yes, sir.
Oh. So after discussion of stock notation, let us try to understand the types of redox reactions in a nutshell. What are the different types of redox reactions? So redox reactions can be further subdivided into 4 types. Combination reactions. So as the name implies, what is the meaning of combination? Combination means addition. Okay, the 2 molecules are combining. So in all the reactions where molecules combine with each other are referred to as combination reactions. So let us see whether it is redox or not. So prior to the combination, both carbon and oxygen had oxidation number of 0, because I told you in pure elemental state it is 0. But after they combine, oxygen usually shows -2. And what oxidation state will be shown by carbon?
+4.
+4. Okay, so it is a redox reaction, and in this type of redox reaction the elements are combining. So all those reactions where redox reactions where addition of molecules is taking place are referred to as combination reactions. Just opposite to combination reaction, where large molecules undergo dissociation, are referred to as decomposition reactions. Decomposition reactions. The second type of redox reaction, say potassium chlorate upon heating gives potassium chloride plus oxygen. And we have got this reaction before while discussing the mole concept. So here it was a single molecule and it is breaking down into smaller molecules. So in all those reactions where there is one type of molecule on the left hand side and more than one type of molecule on the right hand side are referred to as decomposition reaction. So they are redox. Why? Because if you look at the oxidation numbers, chlorine individually, if you calculate it, it will come out to be +5. Here it is minus, it is +1 and it is 0. So there is change of oxidation number going on. Chlorine is the one which is showing the change. So therefore it is called decomposition reaction. Third type of reaction is called displacement reactions. Displacement reactions. So what do you mean by displacement reactions? When one element displaces the other from its normal position, it is referred to as displacement reaction. Say for example, we have Cr2O3 combining with aluminium. And after the reaction, aluminium is found to displace the chromium from its oxide. When you balance it, it will come out to be this. So it is very much clear that in displacement, what is happening? Who was previously associated with chromium? I mean, oxygen. Was it not chromium? And after the reaction, now who is associated with oxygen?
Aluminium.
Aluminium. So both aluminium and chromium are undergoing change in the oxidation state. When aluminium was non-bonded, it was 0. But when it displaces the chromium and takes its position, now aluminium develops a +3 charge. And chromium previously was +3, but when it is made non-bonded in pure state, now it develops oxidation number of 0. Clear or not?
Yes, sir.
Now the most important and different type of reaction is the fourth one. This you must know, disproportionation. Disproportionation reactions. The other three is very clear from their name. Disproportionation. Correct the spelling. Disproportionation. Disproportionation. So there are 4 types: 1, 2, 3, and 4. So I will now give you the details of what is disproportionation reaction. Have you written the first three?
Yes, sir.
Okay. So disproportionation reaction or definition too important hoy, and examples are equally important. What is disproportionation reaction? Bhalke buzilwa. So there are certain redox reactions where the same substance undergoes simultaneous oxidation as well as reduction. The type of redox reactions in which the same species undergoes simultaneous oxidation as well as reduction. The same substance or same species undergoes simultaneous oxidation and reduction. Let me give you an example. ClO3 minus is changing to Cl minus, ClO minus changes to Cl minus, ClO3 minus. Now what I want you to do is to calculate the oxidation numbers of chlorine in all the three and tell me what is the oxidation number of chlorine in this, and this. This one let us calculate. Chlorine, let us say, is X. Oxygen is -2. Overall is -1. So what is the oxidation state of chlorine?
+1.
+1. We need not calculate oxidation number of chlorine in chloride. It is directly visible. It is -1. What is the oxidation number of chlorine in ClO3 minus? How much? Plus
5.
5. See whether everyone is getting or not. All of you are getting it or not? Here, for the sake of convenience, let me put -1. So here you see, from this to this, there is a decrease in the oxidation number. And if there is a decrease in the oxidation number, what process will you call it as? Oxidation or reduction? If there is a decrease in the oxidation number, what will you call this as? Oxidation or reduction?
Reduction.
This is reduction because gain of electron is occurring. And what will you call this process as?
Oxidation.
+1 is becoming +5. So there is a loss of electrons. So is it not oxidation? Yes or no?
Yes, sir.
So the same ClO minus is undergoing reduction as well as oxidation. There is no outer agent. It itself is oxidizing itself as well as reducing itself. So we can say that if you want to generalize this type of reaction, I can say that if there are two species A plus A, then one will be oxidized and the other will be reduced. Isn't it?
Yes, sir.
So this is undergoing oxidation and this is undergoing reduction. Clear?
Yes, sir.
So can we say the same substance is acting as an oxidizing agent as well as a reducing agent?
Yes, sir.
Yes or no?
Yes.
So in this proportionation reaction, the same substance acts as an oxidizing agent as well as a reducing agent. Clear?
Yes, sir.
Now the question arises, what kind of substances can show disproportionation reactions? Those who are at their highest oxidation state, those who are at their lowest oxidation state, or those who have intermediate oxidation state? What kind of substances can show disproportionation? What do you think? We have discussed today that an element has a range of lowest oxidation state to highest oxidation state. Now, what kind of species can show disproportionation reactions? Those who are at highest oxidation state, lowest oxidation state, or intermediate?
Intermediate.
Very good. Intermediate. They have to be intermediates because if they are not at intermediate state, they cannot be oxidized or reduced simultaneously, isn't it? Clear or not?
Yes, sir.
So suppose I am asked the question, out of HNO3 and HNO2, who has the possibility of showing disproportionation reaction? What will be your answer? HNO2, because in HNO2 nitrogen shows intermediate oxidation state, but in HNO3 it cannot show because it is already at its highest oxidation state. So in the range, if it has already achieved the highest value or lowest value, so it cannot undergo simultaneous oxidation or reduction. Is it clear?
Yes, sir.
So that has to be taken care of. So if you are given species and you are asked that can they show disproportionation reactions or not, so you will have to first find out its range. After finding out the range, you will have to see that what is the oxidation state of that particular element in the given ion or compound. Is it lying in between? If yes, fine, it can show disproportionation. But if it is already at its highest position or lowest position, it cannot show. Clear?
Yes, sir.
ठीक है. So today I end up the class with types of redox reactions. Next day we'll discuss balancing of reactions with the help of ion electron method and oxidation number method. Thank you. Good night.
Thank you, sir. Good night.
Good night.
Thank you.